So you're allowed to rotate any row or column as many times as you want, and you're trying to get the maximum sum of the top left corner. So of the n by n matrix of that. So it's like, I don't know, it's kind of, the way I was thinking of it, it was like a permutation of all the possible, ways you could reverse a row and column kind of deal. But Adam had an idea, I think, about a much better solution to that. It's just like, it seems like almost all the problems I find on here, I'm like, oh, you have to do some kind of permutations of it. So make sure this is up. And as you can see, the matrices can get really big too, or not really big, I don't guess, but it's 2 times 128 would be your largest possible matrix. I wish they gave more sample inputs. Yeah. They also give you a queue, it's the number of queries, and then each query contains n. So it's like they can ask for more than one matrix. So at least that's my understanding. So you would have to output the maximum sum for each one. Yeah. So really, the maximum amount of space, you could have to make for it would be 16 times 2 times 128. Yeah. But as far as the actual rearranging, it's a little bit vague, I think. It's like, can you flip a row and a column, or just a row, or just a column? Yeah, as I say, here's their explanation. Let's see, can y'all see that?
Okay, so if we take the maximum value of the outer 4 corners, the inner 4,
It won't just be corners though. Well, you're saying
6, 15, 49, 32, like the maximum of those, and a maximum of 42, 83, 98, 114.
so. This is like your start out matrix. You're saying
Take 4 corners first. No, like 4.
okay. Like 112. Alright. And
Take the max value of that, which is 119. Then you do the max of the inner 4, so the 125, 5, 6, those, 125.
But would it work for larger than 4x4 matrices? That's like I said, I wish we had more than one
Yeah.
input. We can try that.
I mean, it'll work for like,
But
it'll work for even.
the four corners are easy. That's, if you have an array, call it R, just call it A. That's like A0, A, or since it's a, yeah, A00, A0, 2N, A2N, 0, A2N, 2N. Then the inner ones would be,
2 divided by 2
if
minus
it's
1.
more than 4, like, say you had some things here and here too, would you
But
grab,
It's 2 in though. So it's always going to be even.
that's true.
Right. So we don't have to worry about the case of odd.
But if that were the case, you would grab, would you grab starting here and go like all the way down that? Or are you talking about like just the very inner ones?
Well, with that, you have to pick the top 9. If you had a, for 6 by 6, the upper fourth of a 6 by 6 is 3 by 3.
So it'd be like these?
Yeah, if that was a 6 by 6, that would be the top left.
Okay. And then you would take those and those.
Well, it'd be the sum.
Yeah. It'd be the max.
Sum of the top left, right?
Right.
I don't want to do it. Let's do that. Because like my thought there is that like you're taking the max value of what of any of the transformations you could take to move that number up into the top left. Like you can put 119 in the top left in any way you want. It's like a Rubik's Cube where you can move a corner any other corner of Rubik's Cube.
Well, the thing is, I'm saying like would you be taking the like complete inner middle part, or would you be taking like?
No, you'd be taking like its complement, essentially. So like
In this case,
at 1, 1, its complement is 6, 6, right? 6, 1 is 1,
Yeah.
6. And so like 2, whatever that is, right there, its complement is down there in the corner.
this
And then its other complement is up there in the corner. So like those, each other's complement.
so you're saying you would take?
You wouldn't take all of them, you would just take those 4.
Oh, you mean like these 4?
Yeah.
Take the 4 corners, okay.
And then for like,
Yeah, I get you. Yeah, that makes sense. So, corners.
yeah, it's like that. All of the ones.
You
just
keep
do that
doing
for
that?
everything.
For everything?
Yeah. For everything in the 3 by 3.
So it'd be kind of a recursive thing then.
Yeah.
Alright.
And then you do that for the 2, 2, and 2, 3, and all those as well. You do it for the whole thing. No. It'll be the bottom.
Just the ones next to it?
Yeah, because you're only doing pairs of 4. It's a pair of 4 right there. Groups of 4. So that one at the bottom. No.
Well, I know, but that would be for those.
Height.
Yeah. So it'd be like those two, and then for these would be those and. Okay, so do we write a solution? We know it's recursive, so, or at least the obvious solution would be recursive.
I mean, I don't know if that's even possible. There might be a way that you make transformations
Jordan, you're in linear algebra. What's the right transformation? Yeah. Find the eigenvectors for us. It's like part of me feels like you actually could do some linear algebra wizardry with it. Yeah. So. I feel like if you did do it recursively, though, with a matrix that actually was, 128 or 256 by 256, that would be a lot of recursive calls, and you're gonna run out of memory.
For this instance, you only need like a for loop that goes from 1 to 3 and 1 to 3.
Right.
So you only check it 9 times. You have to check 4 locations 9 times. You check 0 for like you check the starting, 2n minus the starting, 2n 0, 2n minus n.
Yeah. So I mean, doing it that way, it wouldn't be recursive, would it?
No,
No, you just doing loops, yeah. I mean. Yeah, I don't know if we're gonna be able to solve this one in that amount of time, though. Think you can do it in Java? No?
I don't know if it's right.
I was gonna say, I don't know if it'd be fast enough.
You can apply this to Python.
Alright, so
No, the operations
I had
in
the
Python are like
had the input there though.
in squares.
Alright. The thing is, like I said, you can do more than one query too, so you'd have to say. Don't even have to save that. But, yeah. So that does the input. Yeah.
2 for loops.
I'm gonna rename the matrix M because I'm gonna get pretty tired of referring to it as matrix later. 2 for loops.
That's how I know Python's probably.
Oh wait, I don't need that I either.
You probably like enumerate some Z in Python, but you've done 2 for loops. Each of them from 0 to n.
To n or to n times 2. Right.
Because we only want to check that upper 4. And then you're going to get the maximum value of.
Probably gonna need like maximum value of the corners.
Well, the complements of each other. So
Yeah,
it's
but
like,
how did you graph
it's going to
that?
be n. Because if it's from 0 to 3, it's going to be n and then 3 or like n minus n. Like, well, for I.
Wait a second. No, never mind. I was trying to think of a shortcut way of doing that. 'Cause it's like there's clearly a pattern over there.
Yeah.
Yeah. Basically, you're given a 2n by 2n matrix, and you can flip any column or row as much as you want, and you have to output the maximum sum of the top left corner. So if it's a 2n by 2n matrix, it's the maximum sum of the n by n submatrix, basically. So,
Like the maximum sum of what?
like, So they give this matrix, you can flip any row or column, and you're looking for the maximum sum of the top left corner. So this is a 2n by 2n. So this little sub matrix is n by n. But so yeah, like you can flip that column if you wanted, or you can flip this row, whatever you want, but you have to output the maximum sum that you're able to get in that corner.
Okay.
So what we were thinking, the 4x4 is obvious, like Adam pointed out, all you do is take the four corners, you ask what's the maximum of those, it's 119, then with the inside, like you keep going, the next four corners, what's the maximum of those, 125, and then you take the sides, yeah, and get the maximum of those, that's 56. You do the same for the top and bottom, it's 114, and then add those up and it's your answer 414. Then we're like, okay, what about matrix C is larger than 4x4? So we're trying a 6x6 matrix. And I mean, it's basically the same thing, but we're trying to think of how to write it. It's like you take the four corners or the complements. So the complement of that corner is this corner, complement of that corner is this corner. And then you move inwards. Well, for those four, you'd also have the sides there, sides, and yeah, those sides. Then you'd move in, take the four corners, so on, take the top and then sides and so on. And you keep doing that. So it's like for the outermost layer, you would have some kind of sum, and then for the innermost one, you would have another sum, and so on, and then you just grab the maximum of those, is that right? Sort of.
You would take,
I think I'll miss some cases though.
so like where it says up there where it's 1,
Yeah.
you have a maximum of its complement. So its complements being 1/6, the dot, and then it is 6.
Right.
2, its complements would be 2, 2, and then 5 and the dot, or 2 dot, 5 dot.
This one.
No, the number 2 up there.
Yeah.
Dot. Dot. Its things are 2 dot across it, 5 and dot across your line, right?
Yeah.
And then the 3 is the 3, the dot, 4 the dot. And do that for the 3x3 up there.
Yeah, you should come up here.
So we want to find for this 3x3, we want to find all of its maximum complements. So here is here, 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 here. Find the max. There's here, here, here. For this one, it's here, 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 and then you do that for here is this one is here, 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 here. This one is here.
So could you write it in pseudocode?
That's what we pretty much got, right?
You could start by reading into the 4 arrays and find the maximum of it.
It's like split it into four corners.
Yeah. So you can split it into 4 corners, find the maximum. That would be easier than trying to flip everything around at the beginning.
Well, I was thinking like if this is 0 and this is 5, we'll say you just read 0, 0, 0, 5, 5, 0, 5, 5, which is just your starting I minus 2n plus 1 or whatever, and then just
Yeah.
Right.
Yeah, and then it'd be like, again, but with this.
Yeah, then
again.
that way backwards, and then it would be I, and then, that twice.
Yeah.
Well, it's not I, it's I, J. But
Yeah. Alright.
But we need
I'm gonna
to
pretend like I know entirely what I'm doing.
My reason for thinking speaking for is just a decent more code. I know that it's not that bad like that, but
Yeah. No, yeah, you're right. It would be easier. It should just be 4 lines of code.
Everything should just be
It's
4 lines of
4
code.
well, not
There's another
entirely.
marker if you want.
Has
If you want to
yeah.
brainstorm. Well, so, I mean,
No, it's gonna be well. It's ugly, but I don't know if you can do that in a 3-year way. Or Python. But like
I mean, once I have like a solution, I can
I0
probably
is-
make it better.
Yeah, like I0 is,
So,
I comma J.
saying, I'm just gonna start kind of putting some stuff out there. You're talking about MI 0 plus.
No, we're gonna do maximum of those 4.
By the way, apparently you can just feed as many arguments to max as you want.
Okay.
Yeah, in Python, it's pretty awesome.
So it's IJ.
IJ,
Yeah.
it's not be.
Because that's gotta be 0, 0.
Yeah, you're right.
And then
I-
IJ plus 2n minus 1. Is that your order of operations correctly? It'll be 2n minus 1 plus the other plus.
I can put parentheses if you want.
And then just do
Then-
that backwards where it's ji and then ji plus whatever. Or ji.
Would it be JI?
No, it wouldn't. You're right. It would. It'd be I plus the 2n minus 1. And then that's IJ. I'm so confused what I'm saying.
I don't
It's
know.
IJ. It's IJ on all of them.
I have no
That's
idea
right.
what you mean now.
No, IJ. IJ.
I've already done IJ though.
Yeah, well, we're getting I plus 2n.
2n minus
2n minus 1.
So you're saying
2n
2n
minus
minus 1.
1. That should be
J. And then n of
oh
I
then J
plus-
plus that? Yeah.
J, or I, yeah.
That.
And then add that to the big max and then big max.
Oh, add it.
Yeah. Can you do plus equals now with Python?
Yep. You can't do plus plus. Yeah.
Really?
You can do plus equals. Yeah. No one ever does x equals x plus that. It's amazing. Yeah, it's amazing. Syntax sugar, man. Oh yeah. No, you're not gonna work in. HackerRank is so dumb with that. But it's like sometimes it works, yeah. Sometimes it doesn't. Right there.
Yeah, you're missing a row. You're missing parentheses. And then another tab out. That'll work.
It's gonna be a really big number though, won't it? Index out of range. Hold on, let me make sure I created the array right. So pretty print didn't do like I wanted it to. Okay. 112, blah blah blah. Yeah, array is correct.
Where are we wrong at? Did you just print IJ for each of those?
Yeah.
Just do that?
Why that would be? Yeah. I don't know why that would do that. Hmm.
Just one of those cases, print J plus 2 rows. That's it for one.
I know here. I know what I can do. I'll say. Just make it fancy, you know.
There you go.
So it fails 3 times. What?
Wait, it worked, right? Oh, no. No, it fails
No.
On, it fails on 2 0.
How?
Oh,
Oh, wait.
it works on 2 0. Why is it not?
So that'll be 0 plus. What the heck?
Why does it fail first? Shouldn't it start from 0?
Yeah, it is starting from 0. It's failing on the second one, not the first.
Oh, I see. It's not.
Yeah, 0, 1.
It doesn't print, but it works.
So 0, 1 would be 0, 1. Then 0, 1 plus 3, so 4. Wait. That's where it's failing. So that shouldn't be j plus 2 times n minus 1.
What is minus?
Yeah, it would. Would it? That's going to end up with a negative number,
2
though.
minus 1 minus j. Yeah, there you go.
So I need to change that on all these. Yeah, it's an I. Maybe. Probably not, but maybe. Whoa. Oh, what?
That work.
Let's do one of the Python best practices. You want to go for it? I mean, all right. No. Yeah. 5 hackos, man.
It's a lot of time.
Oh, that's a lot of numbers. Ugh. I'm thinking our solution actually might still be correct. It might just be failing because it that was the input, wasn't it?
No, it's the output.
Damn.
Yeah.
Yeah.
Just do that first one. You don't care about the I guess we go.
Is the last center equal to 50 kilowatts?
Alright, so I need to change that to. I think it's right. No, it gets Q first, so.
That's not 2 though.
Well, 2 is in, so these are n by n.
How do we pull up
Yeah.
so
Yeah. And it's expecting 12,781. Yeah, it works on that. So let me try doing all of it. Yeah, it's probably going to be too big. Oh. Well, no, you can't tell until that. Yeah. Figures. We can just repeat it.
Yeah, just repeat that first.
I think it's, yeah. That's what it is. It's failing. It should give 12,781 both times. Why is that failing?
You're not missing big numbers.
Yeah, because see, this goes for every
You're not
matrix.
every time and it's not
Yeah, that's true. But n didn't change in this case, so I don't know. We'll see. I don't get why that matters though. Like I didn't change in, and
because
It's reading the two
it's
as its
reading
own line.
that. Yeah.
yeah.
So it's just like
Ah,
shifting you
jeez.
as a two and
Let's go for it. Oh, wow! A solution in Python that actually worked for a medium problem. Oh man,
That was not a medium problem.
it was.
No.
This is listed as
It
medium.
wasn't a medium. That's not a medium
It was a
problem.
hard problem, wasn't it? Yeah.
That
We
was-
should use Dijkstra's
that
algorithm.
was like a mild problem.
There's actually a Dijkstra's problem on here, and it's like obviously classified as hard, but the submission or the success rate on it was like actually 60-something%.
Dijkstra's isn't hard.
Well, it's not, but
Like how many people look at. Like,
yeah, I was gonna
readers
say
look
it.
at
It
Dijkstra's
has to
and
be
like,
people
"Yeah,
that
I
are
can
like
do that."
already know it and crap. So
It's just a priority queue.
yeah, I should be able to get rid of this without breaking everything. Then again, you should be able to do a lot of things. So
Use tabs.
or we can see if we can optimize this.
Yeah.
Ooh.
I think I can say m equals and turn this whole thing into one line.
Oh yeah.
Yeah, you just put that for loop in one of those.
Wait. Be something for that. I think that might work. Oh no. I was like, this is like for the whole thing. No, that won't work. Let's see.
You
Can
put that
do-
for loop in.
Yeah, you can do this for loop in it.
Yeah.
Yeah. Yeah, pretty print didn't really do anything before, so I was just, it's not worth it. 517. Yeah, it worked. So that reduced one for loop. Oh wait, you can even do this. Oh no, never mind. You have to reuse in. I was gonna just input right there, but no, you do have to reuse that.
Just not, and just say size down.
Yeah, then you're gonna be like doing length a lot. If you really want to, I can, but it's only getting rid of one line, and it's gonna make this line really a lot longer.
Would it be necessary for
I
us to
mean-
do that?
You could put all those
Think
photos
so?
on one line.
You can. Actually, hold on.
That would save 2 lines.
You guys wanna see what we can do? Hold on.
One line.
Yeah. This is pretty hilarious.
Oh.
Yeah, it doesn't matter.
These all have a Python terminal.
Almost, yeah. I just happened to be like messing around with the scikit earlier, so. Let's see, what did he say do? Alright, I need to make a file.
You can help it. Just do your code in command line.
Can you from this like third-party shell though?
Should be able to.
Probably. If not, I could make an alias. It's just it's like a portable application, so.
Just like code and dot or
Let's see. Oh, I doubt I need debug in there. Aw. What? Parentheses and call to print. Oh, okay. I think I've got, no, not in this. Got it in my crappy command prompt though. Alright. Think so. Yeah. That outputs it to that underscore OL.
Yeah, you can do the whole thing.
Yeah. Huh?
You can just do a sum of a 4.
There we go. That's it. That's it. All the lambdas and
Now you can make it real. You do the sum of
Run.
no module name. Oh, it's Python 2
Yeah.
though.
Yeah.
Bro, I think built-in is still in this though. Take.
Aw.
Invalid syntax. I mean, it's also probably having a hard time since we did do like the long like compressed for loop. If you take like just really common Python code though, it usually actually handles it pretty well. It's normally not that long either. It's like oh crap, save that in the wrong place. You say like, you know, for I in range, something like that. It's actually an unbelievably long bit. I'm really surprised it gave it that much, but. Yeah, so let's try it with, I don't know.
a lot of code.
Yeah, it is. Like I can write on Lambda. It does that a lot. Like, that's, I don't know. That's really weird. They probably put a lot of
boilerplate stuff in there.
yeah. I was gonna say they probably put a lot of other crap in there for other cases.
Wait, well, if the code can do the one-liner is written in Python, can you do the one-liner code? Like, can you one-line
The one-liner code. Oh, I like your thinking. Oh. Oh man. Like Visual Studio Code is not even able to like do the syntax highlighting anymore. But one line this, good thinking. Yeah, yeah. Well, we need to see if this actually works though.
Yeah.
So
No, just one line itself with itself.
yeah, but we want to see if this. Yeah, I see what you're saying. I see what you're saying because if it, what have we turned into?
Yeah. And then
Yeah.
yeah.
Parts are stuck over. Oh man. Okay. Let's see.
No.
Yeah, it's not gonna be able to do it. It's probably having the overflow with running this file, so
You want increase stack size with Python?
I don't think so.
Does it flag it too fast? Dash S on
Oh man. It's not, that won't work for the interpreter though. Well, I'm trying to do help with that. Yeah, I don't think you can. Wait, like, can you do that in Java and stuff though? Huh.
You can increase the font size and all that. I don't know if you can increase the.
Probably not a good idea for contests though. 'Cause, like, they probably use the default,
They do.
which I don't know what is.
We can
Imagine pretty large,
run
though.
that nested for lookup.
Yeah, that was a good solution though for the problem. Is that was the actual one? Yeah.
That nested for lookup there, you can just do the sum of that.
Oh yeah, we can do
And then for the I and
for. Alright, hold on. Say that again.
you do the sum of like that, the max, and then you do for range I, or range n, I in range I, j in range n, whatever. Like you do 2 fours back to back in the list.
I don't know if you can
You
though.
do a nested for loop.
I don't know if Python will let you. Like,
yeah. For I, for j,
doesn't remember. I could use underscores. On that. That's a. Oh, maybe I do. Okay. Oh yeah. You have to say like. Well, you could say. Wow. Okay then. All right. Oh jeez.
Separate that, so it'll be sum.
Here?
Yeah, and then open bracket for your max. And then you just do for I in range n, for j in range n.
Oh man.
So
I'd have to do that.
No.
No?
You do it inside of that.
Oh well, yeah. For
I think Visual Studio has parentheses.
Come in handy in those problems when they have a line
Yeah.
on a file, just a bit.
and range in 4J and now I don't even have to say plus equals. Oh wait, yeah I do. Yeah, I do.
Just say print the sum. You get rid of like 6 lines.
I mean,
Just print the sum, just print that.
yes. Yeah.
It's much more harder problem than that's where you can Python.
No.
What's that?
It's something with the.
Equivalent of reading matrix.
Be afraid. Yeah.
Like more-
Oh man. Huh? Oh yeah. It's like push this to
Fine
the
lines
get up
for
later. I will. People are gonna like. Oh man, this is gonna be good.
Oh wait, hold on. Scroll down. The one.
Ah,
Humidity.
but he's using all the lambdas. What if we can do it without the lambdas?
Good luck with that.
I know, but what if we can reduce it to a complete one-liner without lambdas?
It's nice.
You can't.
You would have to for like.
No, you could do it because you could get rid of that for loop.
That's really. the
Can,
only
but
problem.
Well, no, you couldn't because you have to sell line codes. That's using the general one line codes.
yeah,
Parse
you
this
couldn't
in
without
one line
lambdas.
easier.
I'll just add a comment on this, guys. I think you can, yeah. Yeah. I don't like that empty line there. It kind of, you know. Yeah. All right. Yeah. It's like the greatest thing we've ever accomplished.
And the guy under that is like, I can't figure it out.
I don't know. Ugh, look how long it is.
Ew.
It's like no one likes you, Java, except Adam. He does. I mean, yeah, it's like those are both probably that's both pretty good for Java.
Very unreadable.
Yeah, that's true. Of course, a lot of that's the forced width of these markdown like comment things. My solution is here. It was so long he had to paste a link. No. Why didn't you just put it in paste bin? Why put it in OneDrive? This isn't even worth looking at. I give it 3 more seconds.
1,
Well,
2,
you know, OneDrive has to
3.
redirect you.
Nope, it's too long.
Way too long.
It really is. Like,
He did your solution.
Did it? Oh, yeah.
yeah,
Who adds
yeah, he did.
comments to their code?
There's another way to.
Aw, he didn't give us edit access. Not worthy.